So this is the 2.3 rates booklet. Again, you get a nice knowledge organiser. Again, if you do want to pause, then you can and have a little look. But I'm not going to go through that. The same with the keywords. You can pause and have a little look at them. And then just a quick look at the core knowledge questions. Again, I'm not going to read through them all, but you can pause as and when you need. Remember, they get progressively harder as you go down the page. Same with the review sheet. Remember quite some key kind of questions. What happens in a chemical reaction? They must collide. Really focus on your core knowledge because it's where you're going to pick up those easy or marks or easier marks. Things like this is a really key maths skill that you might not have done in maths numeracy yet, but you should have done in science. Improvements, 3 ways to measure rate. Again, please pause as you see fit for what you need. So, the first question was kind of focusing, or the first part of this topic was kind of focusing on boiling and melting points. So give a specific name for the changes numbered. So number 1 is when something melts. Number 2 is when something condenses. Number 3 is freeze. And then number 4, something quite different that sometimes comes up, is called sublimation. Explain why this shows it's a physical change. No new products are being made. We've talked a lot about how ice and water, they are the same chemical makeup, H2O, they're just in a different state. State one other difference between boiling and evaporation. What state is occurring? So boiling is turning from a liquid to a gas quite quickly, whereas evaporation is a little bit more of a slower process. Balance the chemical equation. Remember, we've talked about look for something. So we know we have to have 2 carbons. So there has to be a 2 there. We have got 6 hydrogens, 5 there, 1 there. So we need to times it to work it out. If in doubt, just put 2s, but that one was quite an easy one to kind of look at. Next question then. So you can see how I've highlighted certain keywords. The same mass of calcium carbonate and the same with acid excess each time. And then the question says, state using particle theory which factors may be responsible for different rates. So I've put a change in temperature may be occurring. A could be an increase in temperature, C could be a decrease in temperature. Particles are more energy, so more likely to collide. And then I've written change in concentration. A could be a higher concentration, more particles in the same volume. C could be a lower concentration, less particles in the same volume. So it's 2 different factors. You could have gone with surface area, but to me they seem like the most likely and the more common questions that will appear. This one then started off quite nice with you plotting a graph. You want to hope that you get a graph question. The thing that made this one a little bit difficult was you did have to think about an axis. So you did have to think about an axis, but it was quite a good question. If the original experiment was repeated at higher temperature, the reaction would occur at a higher rate. Explain this using particle theory. So the particles move faster, the particles have more kinetic energy, so more likely to collide. This leads to more successful collisions because remember, particles are always colliding. It's only when they collide with enough energy are they successful. This method can be used to investigate the rate of reaction without changing the method or the apparatus used. State what could be done to improve the overall strength. More repeats, doing it more often, and then you can calculate a mean. That means you can identify anomalies as well. Lots of this booklet, and these are experiments that you should have done in class. But again, if you haven't, in the booklet we've included a little method. There will be videos that we can link to them of us as a department doing them, but I have gone through like key answers here. Again, I'm not going to talk through it all, but just this is something that's quite common for practical experiments, hazard risk control. Then the next question then focuses on the term catalyst. So a molecule which is added to a reaction which lowers the activation energy but isn't used up. So the marks there come from lowers activation energy but isn't used up. The graph to compare the 2 catalysts. So A works at a much lower temperature, or pH, sorry, not temperature, pH, you can see I've done it there as well. pH, it works in a very acidic environment. Remember, here's neutral. These are very strong acidic, weak acidic, whereas B works at a much higher pH, neutral towards alkali. Enzyme C is found in saliva. It works between pH 5 and pH 9. See how I've sketched them off? And then I've done my best to kind of curve it in the middle. The curve slightly maybe over a little bit, but it is quite key to need. Again, another experiment. A lot of this booklet will be full of experiments. Like I've said before, they are all on Teams for you to watch, different members of the department, and then there's just a little bit, if you've missed it and you want to read through it and think about the variables, hypothesis, hazards, and this is a great place to start. This question then is looking at, again, graphs, kind of changing reaction stuff like that. So on the grid, sketch carefully the graph that would be obtained if marble chips was ground into powder. So you are increasing the surface area. So it's going to happen more, it's going to happen quicker. But remember, it's still going to end up at the same place. You don't increase how much carbon dioxide is made, you just make it happen quicker. So higher surface area, more space for particles to collide, more likely to collide, increased rate of reaction. This one then is what I was talking about right at the beginning, about tangents, looking at a tangent. They have given you a tangent line there, and they've said to calculate the rate at 2 minutes. You can see how I've drawn a little dot there at 2 minutes. Now, I've picked numbers either side of that time, making sure that they are equal distance from the 2 minutes. And then you can see how I've gone up and looked at the value on the y. So you're doing the difference in y over the difference in x. Initial rate for S is half the initial concentration for T. Explain the difference in terms of particle theory. S is at a higher concentration, more particles in the same volume, more likely to collide, increase the rate. This is an experiment that we would have done in class, or you would have watched a video of it being done in class. It's called the disappearing cross, whereby you look at an experiment, add them all together, and then when the colour changes and you can't see the cross is when you stop your stopwatch. Here they have increased the concentration of sodium thiosulfate. So you can see that actually as you go down you've decreased it and the time gets faster. State whether the results are repeatable. Yes, repeatable means they've done it a couple of times and got the same or very similar results. So even though these first ones, 1, 2, 3, aren't exactly the same, they're very similar numbers, so they are repeatable. Again, a nice graph, and remember with a suitable line, it doesn't have to be a line, it can be a curve, so please don't just do a line. This is a nice little statement. So it says increasing the concentration decreases the reaction time. I've just talked about that on the previous page. Apart from volume, both reagents, the concentration of acid, name the most important factor. I would say temperature, because temperature we know has a big effect on rate. And then again, there's just another, so that's just talking through that experiment I've just done the past paper for. If you didn't get a chance to do it in class, then there is the method there and kind of key variables, hypothesis, hazards that you might come across.